Right, now the next one is velocity time graph. Now this velocity time graph is not something that you need to joke with. Questions mostly come out in this, both in A-level exam, because I can remember vividly in my first semester 100 level, I saw a velocity time graph and it was a very bit tricky, but I conquered it. Do you understand? And I'm going to be explaining it for you. Then you will learn how to solve it, so you will not fear. Now in this velocity time graph, we call it something of VT graph. You understand the abbreviation of it? Now in velocity time graph, it simply means that you are solving to get your mean acceleration or what acceleration. Now what am I trying to explain? Now this is a velocity time graph. Listen, let me use my black pen. This is a velocity time graph. This. Then I have my t in seconds. Then my v in meter per seconds. This is a velocity what? This is a velocity time graph. You understand? Now follow me closely. Now the line that is moving here, a straight line that is moving here, we call it acceleration. What do we call it? Acceleration. That is what we call this line. Do you understand now? Now I want to explain something that you need to know. And I'm going to be using a random figure. Okay, here it's 0. Imagine I have something of 10 here, and I also have something of 15 here. I have something of 5, and I also have something of 10. And I want to trace this. Do you understand? I want to trace this. I'll trace it like this. I'll trace it like this. You understand? I'll trace it like this. Then I'm going to draw a straight line from this point. This is not perfect though. You understand? I'm just explaining something. A line from here. Now, in this particular thing, I have something of this. You know, you just apply a common sense of what plotting graph in physics. You understand? Now, in this particular thing now, I have to apply a common sense in plotting graph in physics. And remember in acceleration, we define acceleration as what? Change in velocity in respect to time. That is where we have A is now equal to change in V over change in T over T. Now, looking at this particular VT graph. In VT graph, to determine the slope or the gradient, because another name for slope is gradient of a VT graph, you are simply solving for the what? The acceleration or the mean acceleration. The mean acceleration, right? The mean acceleration. Now looking forward to get the value of what my acceleration in this particular graph. Remember the straight line moving here is your what? Your acceleration. Now I'm going to be using A is now equal to change in V over change in T. Understand what I'm doing? Follow me closely. Now I have V. My V here is what? My V, remember this change in V is something of saying V1, which is V2 minus V1, and T2 minus T1. This is what it is trying to say. Do you understand? Now, A, my V2 here is what? My V2 is 10. 10 minus 5 divided by 15 minus what? Minus 10. So I have 5 here divided by 5, which is equal to 1. So it simply means by acceleration is what? 1 meter per second square. Yes, 10 minus 5 is 5. Yes, 1 meter per second square. So I've gotten the acceleration of this particular graph. Do you understand what I'm trying to say? It is very, very simple. Imagine I remove this, put 20, I'm going to subtract. Simple. So I want you to take this rule. This is rule 11. Now this rule 11 says that when you are I think I've said it before, but let me just repeat it. Rule 11 says that when you are calculating when you are solving, or let me say when you are using a VT graph and you have it plotted V against T. Remember this is X. No, this is Y axis and this is X axis. This is Y axis and this is X axis. And you have this kind of VT graph. and you are asked to solve, but you are not asked to, like, you are not given the question directly to get the acceleration. All you are solving is what? Your mean acceleration and acceleration. Let me repeat that rule. In a VT graph, solving for the gradient or slope of a VT graph, you are simply solving for what? Your acceleration. In a VT graph, and you are asked to solve for a gradient or a slope, you are simply solving for what? Your acceleration or mean acceleration. I hope it's well understood now. Yes. Now, I want us to look into another thing, because I've given you guys solid 11 rules. It's remaining one rule, and the 2 rules we are going to be applying it in this VT graph. Now, in this second one I want to drop, I want us to take note of this first. You understand? I want us to take note of this first, and we'll solve a solid question on it, and I'll give you another rule to take note of. Now, I have a VT graph like this, V and C. Do you understand? And this is my 0. I have a line, I have a line, and I have a line. All right. So follow me closely. I want to explain something. This is what we call what? We call this place, this particular line that is accelerating, we call it acceleration. We call it acceleration. Then this particular thing, this straight line that is moving horizontal, we call it uniform or constant velocity. Uniform or constant what? Velocity. Now this one we call it what? Retardation, or what? We call it retardation, or what? The acceleration. The acceleration. This is what I want you to take note of. I hope you have grabbed these points now. Yes. So I want us to solve questions so we can know how to do what? Apply this particular VT graph, and also how questions normally comes out in it. You understand? Yes. Now let me give you the last rule, because I want to explain everything, because when we start solving questions, because we solve up to something of 8 questions in this VT graph. 8. Because I want you to understand fully better of this VT graph, because it is very, very crucial. Excuse me. Now, in this VT graph, the last rule is that the shape of a VT graph determines the area of what? The VT graph. What do I mean? This shape is what? And in the VT graph, in VT graph, we normally have 3 shapes in VT graph. Number 1 is the rectangle. Number 2 is the trapezoid. Number 3 is the what? The triangle. Trapezoid, triangle, and what? Rectangle. So you know the what? The formula for rectangle, trapezoid, and so on. Now, this is the formula for trapezoid. But before I write out the formula of trapezoid, I want you to take note of this. That in rule 12, it states that the shape of a VT graph determines the area of what? Of that VT graph. Do you understand what I'm trying to say? The shape. Now, looking at this is a trapezoid. Do you understand what I'm trying to say? Yes, this is a what? A trapezoid. So we are going to be solving questions. You understand what I'm trying to say? So we are done with the 12 rules, and I want us to inculcate that 12th rule, that number 12, which is the last rule in this VT graph. The particular question I'm about to read out, it is not among in the questions that we are going to be solving normally. Do you understand? I want to use this to explain something so you understand what I'm trying to say. Now, in that 12th rule, that number 12, I say that the shape of a VT graph determines the area of the distance. Or like anyhow you can put it, just know that the shape of the VT graph determines the area. Simple. Do you understand? So understand this now. Now let's look into this question. It says, wait. The question says, during a train session, a footballer accelerates uniformly from rest for 10 seconds and attains a velocity of 30 meters per second. He later moved at velocity of another 30 seconds before eventually coming to rest after 10 seconds. Then A, they told us to do what? Represent the above information using the appropriate what? Graph of motion. They are simply asking us to represent it in a VT graph. Now, representing something in a VT graph is something that is very, very simple. You understand? It is very, very simple once you follow the questions carefully. Now, let's examine this. Let's examine the graph. Now, the question says, let me draw a VT graph first. Let me draw the graph. So now this is it. I have my V, which is this. I have my T, which is in seconds. Then this is in meter per seconds. Then the question now says, during a training session, a footballer accelerates uniformly from rest. Yes, they said uniformly from rest without bending. This is not straight. Do you understand? Then uniformly from rest for 10 seconds and attains a velocity of 30 meters per seconds. Now this is my what? Velocity. My velocity here, they said is what? 30 meters per seconds. Then they now say for 10 seconds, and it's going to be like this because this is my time, 10 seconds. So they now said he later moved at this velocity for another 30 seconds. Now in this question, it simply means that the person maintains this 30 seconds. You understand? This person simply maintains this 30 seconds and it moves like this before eventually coming to rest after 10 seconds. Before eventually coming to rest after 10 seconds. Now, how am I going to complete this graph? Look at the board. Now, this question says, it says, during a training session, a footballer accelerates uniformly from rest for 10 seconds, which is this, and attains a velocity of 30 meters per second. He later moved at the same velocity for 30 seconds. I'll draw it here. Another velocity for 30 seconds. Now, am I going to write 30 here? No. What am I going to write? 40. Why am I writing 40? Because if I subtract this, I'm going to get the 30 of this. Imagine they said 50. I'm not going to write 50. I'm going to write 60. In case I subtract it here, I'll get the real value of this. Now, it now says, but eventually comes to rest, eventually coming to rest after 10 seconds. Now, coming to rest. This coming to rest after 10 seconds. Now, in this particular thing, am I going to come and write 10? No. What am I going to write here? 50. Why am I writing 50? In case I subtract this from this, I'll get what? 10. Simple. Now, we have represented what they gave us in the question. This is how to represent something in a VT graph. Now, in the question, we are asked to solve for the total distance covered by this footballer. Excuse me, I'm going to be explaining something here. You need to pay maximum attention. And I'm going to be, remember when I said that we have three shapes in VT graph: the triangle, the trapezoid, and the rectangle. Now, you know I can use the trapezoid to solve for these ones. Now follow me. Looking at this question now, or let me hold my phone because I'm going to be calculating something. Now this is the area, this is the formula for trapezoid, which is A is now equal to half A plus B multiplied by height. You understand? So now I'm going to be using this to solve. Then this is the formula for rectangle, which is length times what? Height, or we call it what? Width. Then triangle, which is what? Half base multiplied by height. Now this is the three formulas: trapezoid, rectangle, and what? And triangle. So I'm going to be making use of trapezoid first. Now this is how to resolve for trapezoid. My A plus B, and what is my height. Now follow me closely and listen. Pen down something. My A, how can I get my A? Now my A, to get your A and B, in which if you are using the formula for trapezoid, in which that is the one I prefer most, you will just mark the straight line in the VT graph, the constant line in a VT graph, the uniform line in a VT graph. Now what do I mean? This is a uniform line from year to year. From year, let me use Bloomberg. From year, which is from year. From year. You understand? This particular line is my A, which is from 50 to 0. This place is 0. You understand now? Is my A. Then, where is my B? My B is from here. My B is from here. Now, where is my H? My H is here. So both of them are the same thing, since they are crossing at this point. You understand? They are crossing at this point. Now, I'm going to solve question. You will see what I'm trying to explain. Now, my A is what? 50 minus 0. 50 minus 0 is what? Which is A, is now equal to 1 over 2 multiplied by A is what? 50. Understand what I'm trying to do? 50 plus my B is what? 40 minus 10 is what? Because the line B is stopping here now. Because this is not a straight line. Because it reaches at this point and bend. So it is not a straight line. So my B is what? It's 10. It is 40 minus 10. Sorry. And it is what? 30. Let me wipe this place out. Then I have to get my height. How am I going to get my height? Remember, this is your height. And it is here, which is what? 30. So the next thing I'm going to do is A is now equal to 1 over 2 multiplied by 80 multiplied by 30. Now let's subtract. I have 80 multiplied by 30. Then divided by 2. Divided by 2. I have it to be what? Equals to 1,200 meters. Yes, because the question says the total distance. So this is my final answer. You understand? This is my final answer. I've solved everything that they need in this particular question. And you go your way. You understand? Now, I want to use triangle method. You understand? I'm going to use triangle method and also use rectangle method on like at the same time. You understand? For those of us that like strength, yes, because some of us like using long method. Because me, I'm going to be using this trapezoid to solve. Now, in case I want to solve using this, like I want to solve, I'll bring out this part first. Bring out this part solve now and now solve. Listen, I'm going to do it now. Now, this is a part on its own. I'll bring out this part. Now, at this point now, remember for rectangle, it is what? Half base multiplied by height. Then my base, you look for your base. Your base is from here to here. You understand? Because this is a triangle. This is a triangle. This is your base and this is your height. This is something that we call, I think, vertex or something. Now, multiply by your base, which is 10 minus 0, will give us 10 multiplied by your height, which is 30. Will give us 30 multiplied by this is 300. Divided by this will give me what? 150. I've gotten for this part. I want to solve it one by one for those of us that like stress. Now, this is for rectangle. Rectangle is from here to here to here. Now, rectangle is what? A is now equal to length times width or length times height. Now listen. My length here is what? My length, which is from here to here, which is 40 minus what? 10. Will give me what? 30. Multiply by 30, which will give me what? I think 900. Let me just check. Will give me 900. I'll solve for it. Now, going to this part. Going to this part now. Pay maximum attention. I have A. is now equal to, this is the triangle part, and this is the part that is deaccelerating. Now, and it is half base times height, 1/2. My base here is what? 40 minus 10. Pay maximum attention. 40 minus 10. Why? It is deaccelerating. In case they said, okay, it is accelerating, it is going to be what? 50 minus 10. Do you understand? So it is going to be 40 minus 10, giving me what? Minus 10. Then I have my height. Or yes, my height. My height is what? 30. Look at the board. My height here is what? 30. So I have it to be what? Multiplied by 30. Then solving this, it is going to give me what? 150. Yes, solving this is going to give me what? 150. You understand why I did now? Because it's still the same thing with this part and this part. Now I will sum up, which is 150 plus 900 plus 150. Then this plus this is 300. 300 plus 900 is what? 1200 meter. You can see both of them are the same thing. So I advise you to make use of the trapezoid method. You understand? The trapezoid method. Now let's solve the real questions. Alright, now let's solve questions based on this velocity time graph. And we have solved an example. And that example is an A-level question. And it's very, very simple. Do you understand? Let's solve more tricky questions, then we move. Now, looking at this number 15, it says, from the velocity time graph shown above, which of the following quantities cannot be determined? Cannot be determined. A, total distance traveled. B, initial acceleration. C, the acceleration. D, initial velocity. The correct option is what? Option B, which is initial acceleration, because the acceleration is not moving forward. It just attain a constant velocity or uniform velocity. You understand? So grab it now. Now question 16. The diagram above shows the velocity time graph of a vehicle. Its acceleration and retardation respectively are what? Now let's solve. Remember that retardation is in a negative form, acceleration is a positive form. So we have A is equal to change in V over change in T. Now, coming to this, the point that it accelerates, then the velocity is what? 80 minus 0. Then we have our T is 20 minus 0. Then we have 80 divided by 20, which is 4 meters per second. Yeah, this is the acceleration part. Then the acceleration part, which is also change in V over change in T. Then our velocity is 80 minus 0. Then coming to the, what are they calling it? Coming to the time, we have it to be what? 50 minus 90. And it is what? 80 minus 40. Which is going to give us what? Minus 2.0 meters per second. Now, coming to this question, the retardation is not in a negative part. You understand? Then, let's look into the question to know which one have the correct option. Option A, no. Option B, yes. Option B is correct. What do I say? Option B is what? Correct. Which is the acceleration is 4. Then the acceleration is what? 2 meters per second square. Meter per second what? Square. Now let's solve question 17. Let's solve question 17. The diagram shown above shows a velocity time graph. The statement that is true about this motion is that what? The car decelerates between points F and H. Point F and H. Look at that diagram. No. Because at point F and G, it has a constant velocity. Now B has a constant speed between E and F. No. At the point of E and F, it accelerates. Yes, it accelerates from rest. Now, See, accelerate between F and G. No, it didn't accelerate between F and G. It have a constant velocity between F and G. Now, in D, has no acceleration between F and G. Yes, coming to this D, it has no acceleration between F and G. It is a constant velocity that is uniform to it. You grab it now. Now let's solve question 18. Question 18 says, from the velocity time graph shown below, or from the velocity time graph below, determine the total distance covered. Now in this particular question, I'm going to be using trapezoid method because I'll be using the most easiest method. Now coming to this particular trapezoid, look at the diagram very well. Look at examine the diagram. And we are asked to get the total distance, which is going to be what? Half bracket A plus B bracket what? H, which is for trapezoid. I have 1/2. Then my A is what? From 30 to 0, which is 30 plus. My B from 25 to 10, which is what? 15. Then my height is what? 20. So grab that point now. I explained this very, very well. Do you understand? Now, 1/2 into bracket 45 multiplied by 20. Now let's multiply. I have 45 multiplied by 20 is 900. Then 900 divided by 2 is 450. Then our total distance is what? 450. Now let's look into the option to know which one is correct. Option D is correct. Even though you use the other method to solve, you still arrive at this answer. But the thing here is just that you are going through a lot of stress. You understand? So that is why I said I'm not going to use that method because it's too long. All I need from you, just get this trapezoid method. Alright, so we have solved from question 1 to 19 and it's remaining one question. So I'm not going to be solving that one question. You understand? You are going to be the one to solve it for me. Do you get? You are going to be the one to solve it for me. And it is going to be under VT graph. I want to know if you fully understood what I explained under VT graph. You understand? And we are done, we have come to the end of this video and I hope you enjoyed this video. So if you want to know more about Noble Team is an online educational platform that provides quality lectures for students preparing for WAEC, NECO, JAMB, and any kind of O-level exam you will think of. Do you understand? We are fully available in it and we provide intensive and top-notch lectures. So if you want to know more about us, my number is on the screen. You can contact me on the screen or you can check the description of this video. There is a link there. You can visit our website to know more about us. So make sure that you do your assignments and you drop your answer in the comment box. And trust me, I'm fully available in the comment box to answer any question. You understand? I'm fully available in the comment section to answer any questions. Just you are free to open and answer and drop your questions rather. You understand? Waiting to see you in the next video.